Hello, and welcome to another OpenShift Commons community meeting. It is February 14th, and welcome, Luis. Today we have a special guest. I'll let you introduce yourself, and then I'll go ahead and hand it over to you. And thank you for being here.
Thank you, Karina, and very happy to be here in the OpenShift Commons community session. So thank you for having me here. Okay, my name is Rico. I'm product manager for Astra at NetApp, and Astra is this piece of software that we have in NetApp to provide data management and data provisioning for the Kubernetes world, no? And that obviously includes Red Hat OpenShift. Okay, so I'm happy to be here. So the idea of the session, if you let me go on, is this is the agenda more or less. So why NetApp in this container world, Kubernetes OpenShift world? No? We are a traditional storage vendor, no? And what are we doing here, no, in this containers world and OpenShift world? No? Then going through the overview of Astra, the Astra portfolio, do a live demo. Okay, so hopefully the demo gods are okay with me, and then we can go through the Q&A. Okay, so this beacon ship that you can see there, the blue beacon ship is the Astra logo. It's just to make sure our sailor, our Kubernetes has a nice trip, a safe trip. And we have stickers, okay? So hopefully in the KubeCon Paris, you can pass by the NetApp booth, okay, in the expo session, and you can grab some stickers if you like the logo. Okay. So I will go ahead and speaking about NetApp for containers. Why NetApp? Why Astra? And it's because we have a very interesting persistent storage solution for the containers world and for Kubernetes and for OpenShift. No? And it's not just saying that, is also analysts like Gartner. No? So they do this kind of overview of all the storage vendors, especially on premise, how they behave with different workloads, and one of the workloads is containers and Kubernetes. Other workloads are, I don't know, VMware or Oracle or SAP. No? So they analyze all the possible workloads customers are using, and we are, in the first position with our all-flash arrays in the data center to provide the best solution or the best integration with Kubernetes and OpenShift for the containers world. Okay, so this was this review in October 2022, and the reasons for that is Astra, no? How Astra provides this better integration for the Kubernetes world and OpenShift in on-prem, no? And also our Cloud Volumes on Tap, that is our software-defined solution for the public cloud, is also very well positioned. No? And this 2023, last year, they repeat every year, no? And we kept the first position. So other competitors were moving around, but we are still the best persistent storage solution there, according to Gartner. No? And again, the reason this year for that is because NetApp has storage solutions in the data center and also in the public cloud, in the three hyperscalers, main hyperscalers, no? So, and these storage solutions are not NetApp reselling things, but is the hyperscaler jointly working with NetApp and deploying a first-party storage solution there, like Azure NetApp Files or FSx for NetApp ONTAP in AWS or Google Cloud NetApp Volumes in Google Cloud Platform. With Astra, we can provide the same experience, integrating, connecting any Kubernetes distribution in the public cloud or in the data center on premise with any storage solution of NetApp. So the experience is the same. So you can have the same dream that OpenShift provides for the hybrid cloud world. So you can have OpenShift on-prem, you can have OpenShift in the public cloud as a service OpenShift. In the same way, we try to provide NetApp, our technology for persistent storage on-prem and also in the public cloud, and also as a storage service in the public cloud. So it's exactly the same. So not only, the analysts are speaking well about us, also our customers. So we have here two examples. The SAS is the historical analytics company. So they have containerized their own, analytics solution that is called VIA, written VIYA. Okay, and they are trusting on us to provide disaster recovery for all the VIA as a service or analytics as a service that they are providing in the public cloud. Okay, so we provide this data protection and disaster recovery with Astra to them. The same or similar is Airtel. Airtel is a big telco company with 500 million, mobile lines in India, and they are a huge OpenShift user, and they are using Astra to provide disaster recovery and business continuity for their OpenShift clusters on-prem. So this is one cloud example and one data center example, and we can help them all. So this is what analysts or customers say about Astra. What is Astra? Astra is two products. Astra Trident is maybe the first one, formerly known as just Trident. Okay, it's our connector that connects any Kubernetes distribution, included OpenShift, obviously, with any NetApp storage solution in the public cloud or on-prem. Okay, it's exactly the same thing. Okay, and then we have Astra Control that I will speak about more later. It's our data protection, data management, data portability, disaster recovery solution for OpenShift and Kubernetes. Okay, very quickly about Astra Trident. So we have been, doing dynamic provisioning since dynamic provisioning was born at the end of 2016, with Kubernetes 1.4, OpenShift 3.4, okay, in January 2017. So we have been there from the very first moment, providing, the provisioner for our NetApp storage solutions. So it has been 7 years. 7 years in the OpenShift and Kubernetes world is a lot of maturity and evolution. So in this sense, Trident has been tested for many years, no? So providing this dynamic provisioning, okay? Is an open source project, is hosted in GitHub, is supported and maintained by NetApp, and any NetApp customer with any kind of storage solution has enterprise support 24/7 for any issue that they could have with Trident. So they don't have to wait for a GitHub issue to be treated. They can directly open a support case with us. So they in this sense is a better enterprise support, we would say. So with Trident, we connect with any Kubernetes distribution, especially OpenShift. In fact, it's an amazing, amount of customers that are connected to our storage solutions using OpenShift. So it's like the majority of our Kubernetes distribution connected through Trident is OpenShift. Okay, so it's a huge percentage is based on OpenShift. So most of our customers are using OpenShift with Trident. Okay, during all these years of evolution of persistent storage in Kubernetes, the Kubernetes community created this container storage interface API just to try to unify the way all storage vendors, all storage solutions have to provide persistent storage to Kubernetes and to OpenShift. NetApp participated in the open source development of the CSI spec, and we were the first commercial solution providing a CSI version of Trident beta in OpenShift 3.11, okay, again, some time ago. So we have been doing this for a while, no? Supporting customers in this sense for a while. Very quickly, a very super fast summary of some of the features that we provide with Trident. So starting from the bottom, I would say we have all these protocols. So we started with NFS and iSCSI, NFS to provide all these access modes, read-write ones and read-write many and read-only many, and now the new read-write one spot that I forgot to update the slide. So we are also compatible with the new access mode. And also we can provide persistent storage to OpenShift virtualization, because we can provide raw devices through our block solutions and in read-write many modes. So you can do live migration of virtual machines using OpenShift virtualization and using NetApp storage through Trident. Okay, so in this sense, is completely supported. Okay. In addition to NFS and iSCSI, 1 year and a half ago, we introduced SMB for the customers that are, willing to add Windows nodes to OpenShift clusters. So we can provide now persistent storage for the Windows nodes for the workloads that they are running on Windows nodes, like .NET or maybe a SQL Server, Microsoft SQL Server database that they are running on top of OpenShift. We can help them providing SMB. No? This was first developed for Azure, and Microsoft was asking for that. And then we extended to the 3 prescalers and also on-premise. Okay, so we can provide SMB protocol now. Okay, and in the latest release of October 2310 of Trident, last October, we started providing NVMe over TCP, so we can now provide a better scalability and performance for block storage, better than iSCSI. Okay. For the installation methods, we are able to deploy Trident in OpenShift clusters using Helm, Operator. The operator is a community operator in the Operator Hub. Is not yet a certified operator for Trident. For Astra Control is a certified operator in Operator Hub. And also we are able to integrate the deployment of Trident as part of a GitOps strategy with Argo CD or OpenShift GitOps. Okay. In the security part, we have been improving the security for iSCSI and also for the NFS protocols. In the latest release, 2310, we added, in addition to the at-rest encryption that we already have, we added also encryption, in-flight encryption. So you can now encrypt the traffic between the pod and the PVC in an OpenShift cluster, and we integrate with Kerberos to do that. So we provide a high level of security in that sense. Okay. About the CSI specific things, we have been providing snapshots from the very beginning. The CSI snapshots are based on our famous snapshots, no? That are efficient, quickly, and they don't impact the production volumes. Okay. We also provide CSI topology, very, very interesting for stretch clusters in 2 data centers in the on-premise world, or the 3 availability zones in the public cloud, and also the online volume expansion. And we can also provide quality of service, comply with the quotas at OpenShift level, quotas in the Trident level, quotas in the storage level. Our monitoring of Trident can be integrated with Prometheus, so you can have all the monitoring of the Prometheus in OpenShift, plus the things coming from Trident, from the persistent storage part. And we provide also volume import, that is a capability to import an existing volume with data inside a Kubernetes cluster. And this volume can also come from another OpenShift cluster, so you can play with that. and also cross namespace volume access to share PVCs between namespaces, something that is historically forbidden. In the Kubernetes world, we try to help because sometimes applications need to share some data, and we can help with that with this feature. Okay. But it's not only Trident, it's also not only a storage provisioning, we also need to provide data protection for OpenShift clusters and Kubernetes clusters. And the data protection is not easy in the sense we have in one side the data of the stateful applications in the persistent volumes here, and also all the metadata, all the Kubernetes resources, these happy names that we have been learning during the years, the deployment, the config map, the custom resource definitions, the secrets, that are part of the application, but they are not in the persistent volume. They are stored in our happy guy etcd here that is replicated, very well protected, but in different places. No? So with Astra Control, we wanted to provide a solution that is able to give data protection and data management for the Kubernetes applications as a complete unit, no? Data in the persistent volumes, but also metadata in the Kubernetes resources space, no? And that is what we have done with Astra Control, no? Astra Control is the second part of the Astra portfolio, is a solution to provide data protection with snapshots, clones, backups, restores, disaster recovery using storage replication, and migration and portability of applications with all the data from one cluster to other cluster, from on-premise to the public cloud between different hyperscalers. So it's an hybrid multi-cloud data management solution in this sense. No? Technically, very quickly, how it works. Okay, so it's able to connect throughout an OpenShift cluster using the Kubernetes API, and is continuously discovering new namespaces created, new things created, changes inside the namespaces that we are protecting. So if a new PVC appears, we immediately provide data protection for the new PVC. And we gather all the storage information or persistent storage information related in the OpenShift cluster, and we are also able to collect all the metadata, all the Kubernetes resources related to that application. Okay, if we need to do a backup, we have a solution called execution hooks that you can run a script in the pods, so you can for example, put in online backup mode an application, or freeze an application just to take an application consistent snapshot of the application. When we do that, we do this freeze, we collect all the metadata, we do a CSI snapshot of the PVCs related to that application that we are protecting. And after the seconds of the snapshot, of the CSI snapshot, we can unfreeze the application. So we are releasing all the freezing or all the IOs that we have been containing. And then with all the time of the world, we can mount the snapshot, read the contents of the snapshot, and send the metadata and data to object storage in a bucket outside the OpenShift cluster. So just to make sure, if your OpenShift cluster has any problem, you still have the backup outside the cluster. Okay. If you want to restore, or if you want to move your application with the data, we just have to ask Astra to do the restore, and he will restore from the bucket, from the object storage, to a new PVC in the destination cluster, and then it will redeploy all the Kubernetes resources and connect them with the PV that it was just restored, the persistent volume that was just restored. And if you want to move the application, then you can safely delete the application or the namespace in the source cluster. Okay, but not only snapshots, clones, backup, and restore. No, so we do other things that are more advanced, that, for example, Velero or any other backup solutions in the market. No, or we are able to provide storage replication or integrate our storage replication with Astra. So if you want to protect several namespaces with several PVCs, Astra is able to detect all the PVCs, establish replication relationship of all the volumes that need to be protected between two storage systems, on-premise and in the public cloud, or on-premise, or public cloud, or hybrid thing, no? And then it starts replicating all the data. If you have any failure in the primary cluster, you can easily, press the failover button, and then Astra will redeploy all the Kubernetes resources and connect them to the replicated volumes, okay, that have been replicated in the background, okay. So it's a kind of automated disaster recovery for OpenShift, okay. And in fact, if we do this thing, our idea is in the future to integrate with application cluster management and also hosting the Astra Control software piece inside the ACM hub, no? in this infrastructure cluster, okay, just to monitor what is happening in the data centers or between the data center and the public cloud. We have two flavors of Astra Control, two deployment modes. One is called Astra Control Center. It's our software that can be installed in a Kubernetes cluster or in an OpenShift cluster, and it protects from there other OpenShift clusters or other Kubernetes cluster. No? So we support all these distributions plus Azure Stack and Google Anthos in especially focus in the data center, and we do that mainly with our storage, okay? So because we do this advanced protection using our replication technology, mainly we are focusing in helping customers that already have or want to have our storage solution, no? Our storage backend, no? Our storage arrays in the data center or in the public cloud, our cloud volumes on top, or the hyperscalers storage. No? So this is a software, you install it, and you can protect everything. Okay. We have the second flavor or second deployment mode is called Astra Control Service. And Astra Control Service is a service in the public cloud. No? So instead of having to install Astra Control as a software, containerized software, available as a certified operator in the Operator Hub, for OpenShift, you just consume data protection for Kubernetes for OpenShift as a service, okay? So in this sense, you just register for an account in Astra Control Service, and from there you can protect OpenShift clusters in the public cloud, or ROSA in the public cloud, or OpenShift on-premise, okay? Because now, since the latest release, we have a connector that we can, protect clusters that are in a private networking in the public cloud or on-premise. Okay. So with this solution, we are also able to provide all these Kubernetes services, managed services from the hyperscalers. And when we do that, we are not only supporting our own storage solutions in the public cloud, Cloud Volumes on top, Cloud Volume Service, or Cloud NetApp Volumes in Google, Cloud NetApp Volumes in Google, or Azure NetApp Files in Azure, or FSX for NetApp on top in AWS, but also the default persistent storage in these hyperscalers, no? So the EBS in Amazon, in AWS, or the Azure Disk, or also the Google Persistent Disk, okay? So we can protect all the applications, even if they are using other storage solutions like the default hyperscaler storage solutions. The only requirement is we need CSI driver, because we do CSI snapshots, so this is the only kind of requirement for the hyperscalers. This solution, this service is available in the Azure Marketplace and in the AWS Marketplace. No? So it's easier to consume. So that's all from the slides point of view. So I will do a demo now, but just we are available at NetApp for providing a demo for any of you, or doing a proof of concept, or you can also try Astra for free. No, so just going to Astra in our website, and you can just register for a free account. We have forever free accounts to test Astra Control Service. Okay, so you can use the product up to 10 namespaces protected from different clusters, OpenShift clusters, but you can use the full functionality of the product with this free account. In fact, is the same account I'm going to use now for the demo. Okay, so let's do this live demo. Let me explain a bit about the demo environment. So I just created 2 ROSA clusters. I'm going to use Red Hat OpenShift service on AWS, ROSA. Okay, so one is called Commons Main, is in the AWS region of North Virginia, and the other one is Commons DR. Okay, so just to simulate 2 clusters, that is in the Oregon region, AWS region. Okay, I'm going to connect them using Astra Control Service, and I will do this kind of disaster recovery for ROSA, doing backup and restore. Okay, from one place to the other. So let me go through the demo. So this is the dashboard of Astra Control Service. So you have to log in with your account. So you create an account with your email address like this. Okay, and once you have that, you can provide credentials to connect to different hyperscalers, or you just can provide kubeconfigs to connect to the different OpenShift or ROSA clusters that you want to protect here. Okay, as you can see, I'm using the free account, so you have this forever free account to test the product, and also you have pricing available in the marketplaces of the hyperscalers. So in Astra Control we have buckets. The object storage buckets are the places to store the backups. So we want to store all the backups outside the OpenShift cluster, just to make sure that they are safe. Outside, if something happens to the OpenShift cluster, you can still recover from the backup. So here you can see different buckets I have in different regions and different hyperscalers to store my backups. Okay, so they are just the backup destination. I can add a bucket anytime we want. I just have to choose the kind of object storage I'm going to use, generic S3, or it can be also using our own object storage technology on top S3 or storage grid. Okay, you just have to provide the endpoint, the bucket name, the secret key, the access key, and that's all. Okay, and you can add a new bucket to store backups. No, and the bucket can be immutable bucket using S3 lock. So Astra will detect automatically that is an immutable bucket with a retention period, and he will apply this retention period to all the backups he's storing in that bucket. Okay, so this can also be used. No? So the bucket can be as good or as very well protected as the customer wants. Okay. We have also cloud instances. You can see here the different hyperscalers and my accounts in the hyperscalers. And we have main clusters and applications. Okay, so this is the main objects that we are using in the Astra Control console. Okay, as you can see, I already have the Commons main Red Hat OpenShift cluster available here. If this is 125, that is OpenShift 4.12. So if you go inside, you have a look of the worker and control plane nodes, and you also have all the namespaces. Between all of them, I just created my SQL application, SQL deployment that I'm already protecting. We also have the applications. As you can see, I have the MySQL application that is already protected by Astra in the cluster Commons main. So if we take a look to the MySQL application, you can see that we have several tabs here. Data protection tab with snapshots and backups. So in the snapshots, you can see that I can do on-demand snapshots, and I can also schedule snapshots. So you can see here that I'm doing snapshots at the 30-minute, okay? And also I have been doing on-demand backup and on a scheduled backup. The scheduled backup was just 30 minutes ago. This is Greenwich time or UTC. And this is the snapshot for the backup, okay? So every time we do a backup, we do first a snapshot just to make sure that we have this consistent view of the Kubernetes application running in OpenShift, okay? And what are we doing? We can configure, protection policies. So we can do this hourly protection. So here I can define at the 30th minute of the hour, of every hour, you have to do a snapshot. And I want to keep the latest 24 snapshots available. So for doing quick restore or quick clones, okay? And I can establish also a daily policy. So every day at 5 English time, you have to do the backup, and you should keep the 7 latest backups and the 7 latest snapshots of the backup, okay? And I can decide where to store these backups, these daily backups. No? For example, I'm storing them in the Oregon region in the AWS bucket S3 bucket. Okay? You can also establish weekly or monthly protection. Okay? And what I'm doing is snapshot and backup every hour. I'm doing the snapshot and the backup of the data that is inside this persistent volume and also of this metadata part of the namespace. So I'm saving everything. And here you can see 74 Kubernetes resources, cluster role bindings, role bindings, config map, custom resource definitions, the secrets, the deployment definition, the persistent volume claim definition, the role bindings, service accounts. Okay, so I'm just saving everything every time I do a snapshot, every time I do a backup, so if something happens with the data, is corrupted, I can restore because I'm saving the contents of the PVC. But if something happened with a config map or a secret, you can also restore the secret or the config map, part of the metadata or the deployment definition because somebody edited the deployment and it was a mistake and we have to restore the deployment. We can do that instead of having to going through a pipeline, or instead of having to do the going from Git, or in addition to have a GitOps strategy with Argo CD. Okay. You can also use execution hooks. Execution hooks are interesting to do this kind of actions: pre-snapshot, post-snapshot action, pre-backup, post-backup, post-restore. So you can, in the pre-snapshot, freeze the MySQL database, in the post-snapshots, unfreeze the MySQL database to have this consistent view of your MySQL database in the snapshot. And in the post-restore, you can do things like changing the IP in the DNS, or redirecting the traffic, or scaling down the resources used by the application because you have less CPU and memory in your disaster recovery cluster. No? So you can do all these kind of things. No? To help customers doing these things, we have created an open source project called Verda. And Verda is just some script examples of how to protect the most popular stateful applications. So you can have here scripts about how to freeze and keyest Cassandra or Elasticsearch or MongoDB or MariaDB, MySQL, PostgreSQL. No? So in my case, for example, I'm protecting MySQL, so I can go here, I can read how this MySQL script works, okay? It has 2 arguments, one for the pre-snapshot and another one for the post-snapshot. This is the thing that is doing. And I can also take a look to the script, see if it's good, customize it or improve it. Please, if you improve it, collaborate back, okay, because it's open source, no? So everybody will be able to benefit from that. So for going on with the demo, I'm going to add my second OpenShift cluster. So you can add directly clusters from Azure using the service principal credentials, or from AWS using the service account. I'm going to use the kubeconfig to add my cluster. So as you can see, I have here the commons DR YAML. I'm going to use this YAML to connect to my ROSA commons DR OpenShift cluster. You can also use a private root identifier. This happens when your OpenShift cluster is in a private networking in the public cloud, or is ROSA private link or ROSA private in the public cloud, or it's in the data center. No? So we have a piece called Astra connector that you install in your OpenShift cluster, and it does a handshake with our Astra control service in the public cloud, and from there it establishes a TLS encrypted TCP tunnel, and all the communication is through there. No? So we can, in that way, we can protect OpenShift clusters on-prem or in private networking with the Astra control service that is available in a public IP address. Okay. So with this credential, I'm going to click next. So he will use these credentials to connect to the commons DR cluster, and he will scan all the persistent storage there and the storage classes that we are using. So you can see that the default is EBS, and you can see that the GP2, because it's not using the CSI driver, we cannot use it. We cannot protect applications using GP2 because we need CSI. And we have two storage here, the EBS CSI storage classes, and also our FSX for NetApp on tap storage solution that is available and is usable through Astra Trident in this ROSA cluster. Okay, I'm going to choose as the default storage class the FSX for NetApp on tap storage, persistent storage for my ROSA cluster, and I just click add. Okay, so it's just that. Okay. In the meantime, I'm going to show the infrastructure that I have behind for this live demo. So here we have one ROSA cluster, the console of the ROSA cluster. This is the commons main ROSA cluster, version 4.12. Okay, we have also this another ROSA cluster that is the commons DR ROSA cluster, and is version 4.13. Okay, so it's not only providing disaster recovery, but you can also easily clone workloads from OpenShift 4.12 OpenShift 4.13 with production data, just to check if everything goes well if I upgrade to 4.13. Okay, so it's going to help also with blue-green upgrades, or just testing if everything is working is going to work after the upgrade. Okay, so you can do also this kind of things. In the main cluster, you can see workloads. So we should have here MySQL. We have also the namespace of Trident with the CSI pods to provide dynamic provisioning. And you can see that I have a deployment with MySQL, and in the storage side, you can also see that I'm the same information that I saw in the Astra control console, PVC with 2 GB and only 14 megabytes are used. So this is the usual stuff in the persistent storage in the Kubernetes world. So, a lot of storage is wasted, no problem, because we use thin provisioning. Okay, so in this sense, there is no problem. If we go further and check what is in the AWS part, this is my AWS account. So you can see in North Virginia all the instances, for the commons main ROSA cluster, my 3 masters, 2 infra, 2 workers. So this is the normal default configuration for a minimum ROSA cluster. And this is the compute part. We have also here. Oh, shit. Sorry for that. I have to log in again. This is AWS. So we also have the storage part, the file system part. You have EBS, but also as the default in ROSA, but also we have FSX for NetApp on top. That, to be honest, is more interesting than EBS in the sense that when we provide volumes, these volumes can jump from one availability zone to other availability zone. So they are cross availability zone. And we are not charging the traffic, no? So this cross thing is behind the scenes, okay? So you don't get charged because you are replicating volumes between availability zones, okay? So this is behind the scenes. So this is the FSX part. In the FSX in North Virginia, we have a file system, FSX for NetApp on top. This is based on NetApp technology and is called Commons Main. You can configure it as single AC or multi-AC for providing high availability. In any case, the volumes are cross availability zone, so they are available for all availability zone in this region. Okay, so no problem with that. So this is the infrastructure. Coming back to the Astra Control Console, you can see that the Commons DR cluster is already added to Astra Console. So I can use it to do disaster recovery. So for example, this MySQL, I can click here in the actions. I can do a on-demand snapshot, on-demand backup. I can clone, okay, to this cluster or to other cluster, quickly clone. And I'm going to restore, okay. You can restore to original namespaces or also to new namespaces. So the restore to original namespaces will replace everything. In the production namespace, I'm going to restore to new namespaces. I will restore this to Commons DR cluster, okay? And I will use the same name for the destination namespace that in my source cluster, my SQL namespace. I click next. Astra is asking me from which backup or from which snapshot you want to restore. To do the restore, I'm going to select the latest. I can select between all these things. I'm going to select the latest backup available. Okay. You can use restoring the original storage classes, or you can, for example, instead of using FSX for NetApp on top in the source, using EBS in the destination. So you can do also data migration of the storage with Astra, okay? So for example, if you are using EBS and you want to move to FSX because you believe it's better, you can do this kind of thing using Astra with this next thing, okay? Experience, okay? So I'm going to select the FSX for NetApp on top, storage class in the Commons DR cluster. You can restore all resources, or you can also filter resources. So for example, you can decide, I only want to restore the PVCs because the metadata is going to be provided by GitOps or from a GitHub or Git repository. So you can do that, or also, for example, you can exclude a secret because for me, I want to reestablish the credentials of the database or this kind of thing. So I can select, okay, let's exclude this secret or let's exclude these config maps. So you can do all these things to do selective restore. I'm going just to restore all resources. Summary, a warning saying if you have read-write many in the source and the storage class of destination doesn't have read-write many, you are going to have a problem. Okay, and just click restore. So no matter how long it takes, the good thing about this process of restoring your Kubernetes application is that is next. So it's very difficult it's very easy to follow, no? So even my cat can do disaster recovery, with this tool. So you don't have to be a Kubernetes expert, no? You don't have to, I don't know, create Velero scripts or these kind of things. You cannot do that. You don't have to do that. If you want to do that, we have a very powerful CLI to automate everything with Ansible or with anything you want that is based on our RESTful API. And this RESTful API has absolutely anything here, and you can test it directly here in the API. So everything that I'm doing In the console for the demo, you can do it with the API and with the command line to automate it and make it part of an infrastructure as a code strategy. Okay, so no problem in that. Coming back to what is happening behind the scenes, and I'm going to use now the terminal just to see for the terminal lovers what is happening behind. So in the top window we have our North Virginia Rosa cluster because it has no name of the region, and in the bottom window we have our Oregon US West 2 Rosa cluster. Now, as you can see, this is 125 4.12, and this is 126 that is 4.13 OpenShift. Okay. So you can see here we have the MySQL namespace, and here we don't have MySQL namespace. If we click again, okay, I have to log in. Sorry for that, because probably the token expired. So I will do that very quickly. Commons DR. Okay, so repeating the command now, okay, you can see that 2 minutes ago, my SQL namespace was created, okay? So if I see what is inside this MySQL namespace, you can see that we already have a persistent volume that was created 2 minutes ago using the FS6 CSI storage class, okay, this bound, and our deployment that has this pod running, okay? So the restore is already done. The disaster recovery is already done. It took, very little time because it's very small, the database, okay? So it's a demo database, but it's not important how long it takes, or less important than how easy to use is this for doing data protection and restoring things. No? So everybody can do this. So it's quite easy. So this is the demo that I wanted to show. I don't know if there are any questions in the chat that we can go over it. Okay, I have one here. Sorry, time for the questions. What is the support model for using the Trident CSI driver on OpenShift on AWS? Okay. So we don't care about if it's IPI or UPI or is self-managed or is a managed cluster like Rosa. So the Trident experience is the same. Okay, so you just deploy Trident. Trident is going to deploy all the Trident nodes, pods. We can take a look here.
Hi, Lewis. Can you hear me?
Oh, yes, David.
Yes.
Yes.
So I was just wondering more in the, let's say you have an issue and you want to open a support ticket, or like, is it more, NetApp or Red Hat or?
Yeah, it's NetApp, okay?
Okay.
Because Red Hat provides supports of EBS and EFS, okay, that are the drivers that are included in the ROSA managed system, okay? And for these issues, you have to speak with Red Hat. For issues related to Trident, you have to open the support case with us. No problem. You are using NetApp storage solution, so you will be covered, okay? So.
Okay.
So sorry, I understood other thing from
No,
your
that's fine.
questions. Thank you.
So did I understand that there's a kind of a open source available version, but I guess if you want, you can purchase a contract with NetApp for that support, or?
No. So no need for contract. So Trident is open source and is free of charge. And if you are using any NetApp storage solution, you have support for Trident.
Thank you.
So maybe if you are only an FSX for NetApp on tap consumer, okay, in AWS, is AWS the guys that have to redirect to our support, okay, but you will have support, okay. So because FSX for NetApp on tap is an AWS product. Okay, so they are responsible of the product because it's a full product. If you create here a new file system, so this is just another one of the possible FSX products from AWS directly. So maybe they are the ones that have to redirect to our support, but you will be covered.
Thank you very much.
Yes. Another question from Benjamin. How do you plan out the storage space for all the snapshot? This is a very good question. So we have, when we configure Trident with the storage backend, there is a default space reserve, okay? I believe it's 20%. It's called a snapshot reserve. So you can modify this snapshot reserve for a backend and a storage class. So you can do that if you believe your applications are going to, because they have a lot of writing, they are going to change, to have a high change rate and modify a lot the persistent volume, then you can increase this snapshot resource to make sure you have enough space for still keeping snapshots of your highly changed application. Okay, so you can modify the parameter. Okay, everything is steam provisioning. So when you are using a backend, you have access to all the capacity that you have in this storage virtual machine or the storage appliance. So you can restrict that using Kubernetes or OpenShift quotas. You can also put quotas in Trident, and you can put quotas at our on-tap level. Okay, so you can control how the space is used and consumed in the solution. Any more questions? Live questions? People opening the microphones?
I don't have a question, but thank you.
Thank you, Karina.
I'd jump on. Looks like somebody has a question. David?
Oh,
go ahead.
David?
I do. Good to meet you, Luis. This morning when I was, talking to you back and forth on the Slack channel. Actually, I have two
Yes.
for you, sir. How small of a NetApp setup can Astra work on, i.e., hardware-wise? And the second one is, will this work on the edge? Because I know you've been talking a lot about cloud computing and on-prem data center. The preface behind this, Luis, is, a few of us here on OpenShift Commons is more of an edge level, or I guess edge, I won't say specialty is not the right word, but more towards the edge side, trying to figure out, how we can utilize some of these equipment, technologies, etc., in an environment where you don't have a data center, you don't have, all the bells and whistles, for lack of a better term. Does that help, or does that understand?
Yeah,
You get what I'm saying?
the second question is understand. I will have to ask about the first one. Let me start by the second, about the edge.
Okay.
So we have, a specific, very small storage array for the edge. Maybe for people it's still big, okay, or for customers it's still big, okay, but we have a specific model, towards the edge, to cover that space. It has all the on-top technology, so Trident is compatible with that. So if you want to use this kind of a small appliance for persistent storage for OpenShift in the edge, you can use it. Okay, so no problem with that. Okay, but it's not, an Kubernetes native storage solution that is deployed inside a minimum OpenShift cluster of 3 nodes. Okay, so we don't have that. Okay, so this is not that. We have also a VMware appliance for customers that want to use VMware storage with on-tap technology. So we have the storage array in a virtual appliance in VMware, but for the edge, we don't have this software-defined native Kubernetes storage solution to be deployed inside an OpenShift cluster in the edge. Okay, so this is the truth. Okay, the brutally honest. Okay,
That's all right.
and for the first question, if I understood well, you are speaking about how small can be an application defined in Astra. Okay, so
No,
it can be
I'm
as
talking
small
about
as. Is
talking
that
about
the
hardware.
right question or?
The hardware. I'm talking about the hardware side.
Hardware.
Yeah, because the thing is, our thing is, from an edge standpoint, we're looking from a small form factor or kind of a on the go, for lack of a better term, form factor. Whereas if you're, it ties in with the BCDR and that type of stuff, where we have stuff that we go out to, an incident, i.e. Puerto Rico or something like that, where we have to carry a lot of the stuff with us. And if we have to have, if we want to have some type of persistent storage, how do we do that from a NetApp standpoint, and as well as Astra, if we can? I'm not, I'm not sure if we can or not.
The persistent storage point of view,
Mhm.
the answer is my previous answer, the
Yeah.
answer to the question number 2. From the data protection point of view, you don't need anything because you install Astra Control in your data center hub, and then you can manage small OpenShift clusters wherever they are. Okay, so so we only install this if you are in a private networking, this Astra connector to do the handshake with the Astra Control Center instance or the Astra Control service, public service in the public cloud, and that's all. So you don't need to install anything special there. Okay, so it's the minimum thing. Okay, so we can protect that this remote OpenShift cluster, but again, we need to, if we are protecting stateful applications, we need a CSI driver, okay? and CSI driver that is supported by us. So we are already supporting, in addition to our storage solutions, Longhorn, and we are in the process of certifying OpenShift Data Foundation. Okay, so the CSI part, obviously. So we are in the process to support VMware CSI, ODF, okay, and Longhorn is already supported.
Thank you, Luis.
Yeah, sure, David. My pleasure.
And
Any more questions? We are
we have
running out of
1
time.
minute. Yeah, I think we're about out of time unless somebody has a very quick last minute. Okay. Thank you so much again for being here. And next week we have a general OpenShift storage session. So come back next week. And yes, we all appreciate. And oh, I think in Paris, Michael, whoever's going to be in Paris, we can all go talk NetApp over at the NetApp booth also. So we'll see you all next week. And thank you again for being here.
Thank you, Elena. Thank you, everybody. A pleasure. Bye-bye.